today we are going to learn about mirror formula, magnification and sign conventions. Now before we talk about mirror formula and magnification, let's talk about the sign conventions which we will be using while we use the mirror formula and magnification. Now sign conventions that we follow for reflection by spherical mirrors are as follows. First convention is that we always take the object to the left of the mirror. You always draw on the ray diagram. So many ray diagrams you've drawn till now. We've always drawn the mirror in this direction and the object we have taken to the left side of the mirror. This is one of the conventions that we take. Fine. So first is object is always taken to the left of the mirror so that the light falls in the mirror from left to right. Fine. The light should fall in the mirror from left side. First sign convention, the object is placed towards the left of the mirror, so the light falls in the direction left to right on the mirror. Second convention is that we take pole as the origin. All the distances which are parallel to the principal axis are measured from the pole. Pole is taken as the origin. Fine. Second point. Thirdly, all distances which are measured from left to right in the direction of incident light, that means from left to right, are taken as positive. All the distances which are measured, the distances have to be measured from pole, and all distances which are measured from left to right are taken as positive. All distances which are measured from right to left are taken as negative. This is the third sign convention. Next, all distances which are measured perpendicular to and above the principal axis are taken as positive. All distances which are measured perpendicular to and below the principal axis are taken as negative. These are the sign conventions which we have to follow while we use mirror formula and magnification, which we will be shortly talking about. So I'll repeat the major points that we have to remember. Object, first point, object to be kept on the left of the mirror so that the light falls from left to right on the mirror. Second, P is taken as the origin for all distances which are measured parallel to the principal axis. Third, all distances which are measured in the direction of incident light, that is left to right, are taken as positive. So when we start from pole, left to right, the distances measured will be positive. All distances measured right to left are taken as negative. All distances, fourth point, all distances measured perpendicular to and above the principal axis are positive. All distances measured perpendicular to and below the principal axis are taken as negative. Fine. So this diagram, a small diagram, will help you to remember these 4 points which are important to remember in sign conventions. Fine. The statements are given in the NCERT, page number 168. You can refer that. All the statements are given there. But in short, we can remember this way. We will be using these while we use mirror formula to solve numericals. Fine. Now let's move on to the mirror formula. Okay, now mirror formula actually is a formula which relates, let me write the mirror formula, then we'll see what 3 physical quantities are related by it. Mirror formula is 1 by F is 1 by V plus 1 by U. So it relates V, U and F, where F stands for focal length of the mirror which we are talking about, U stands for object distance, and V stands for image distance. Okay, V is for image distance. So mirror formula relates F, U and V, and the formula is 1 by F is 1 by V plus 1 by U, where F is focal length of the mirror, U is the object distance, V is the image distance, which are always measured from the pole of the mirror as we have just discussed. There's one more formula that we have to talk about, and that is magnification of the mirror. Magnification is denoted by small m, and it is defined as height of image to height of object. Fine. Height of image to height of object. And in short, I can say HI divided by HO. You can write H2 by H1 as well as I am writing I and O as subscript so that you can remember that it is the ratio of height of image to the height of object. Now this can also be equal to minus V by U, where V is the image distance and U is the object distance. Now the form derivation of these two formulas are not in the syllabus, but you have to remember these formulas. Mirror formula is 1 by f is 1 by v plus 1 by u. Magnification is hi by ho, which is also equal to minus v by u, and we'll be using these formulas to solve numericals. In the mirror formula, see, if you're given any two of these, you can find the third one. If you're given v image distance and u object distance, you can find focal length. If you're given f and v, you can find u. If you're given f and u, you can find v using the mirror formula. Fine. So now when we use these formulas for solving questions and numericals, we have to follow the sign conventions. Now let us talk a little bit in details about the sign conventions and what sign we can assign to u, v, f using the conventions that we've just learned. Fine. So let's talk in detail, and I'm rubbing, and I draw the diagram of sign conventions that I've just explained to you here at one corner so that we remember what conventions we have learned about. This is, we take P as origin, distances from left to right positive, distances from right to left negative, distances upwards positive, distances perpendicular and below the principal axis negative. These are the sign conventions to be followed. If you remember this, you can easily, with the help of this diagram, you can always easily remember the sign convention. Now if you use these sign conventions, what sign can be assigned to the following terms? Now let's talk about u, which is the object distance. Okay, so object distance u, object is always placed to the left of the mirror. Fine, you always place object in front of the mirror. Whether it's a concave mirror or a convex mirror, the object is always placed in front of the mirror, to the left of the mirror. So object distance should be measured from P, pole. So we have to measure right to left. So object distance will always be negative. That means if you are given in the question that object is placed at a distance of 10 centimeter from a concave mirror or a convex mirror maybe, then you will take u is equal to minus 10 centimeter. U will always be negative. Fine. Let's talk about v, which is the image distance. Let's talk about v of a real image. V for a real image, what will be the sign for a real image? A real image is always formed, till now you've learnt in all the ray diagrams. Real image is always formed in front of the mirror. When the real image is formed in front of the mirror, again the image distance will always be negative. Because real image is formed like this, inverted and in front of the mirror. So if you start measuring from pole, the distance will be negative. Pole to the image distance will be negative. So it will always be negative. V for a virtual image, if I say, V for virtual image will always be, the virtual image is always formed behind the mirror, whether it's a convex or a concave mirror. Virtual means image formed behind the mirror, and virtual image is always erect. So it is formed above the principal axis and behind the mirror like this. So the image distance will be always, if you start measuring from P to the image distance will be left to right, and that will be always positive. So in the question, if it says that the real image is formed in a concave mirror, let's say at 15 centimeter from the mirror, then V will be minus 15. If it is said a virtual image is formed in a mirror at a distance of 15 centimeter, that means V is plus 15. So V is negative for real and positive for a virtual image. Let's talk about height of object. Height of object, object we always take above the principal axis, so it is always taken as positive. Height of image for a real image. For a real image, real image is always inverted. So for a real image, height of image will always be negative because it is below the principal axis. Height of image for a virtual image. A virtual image is always erect above the principal axis, so will be positive. Height of image will be positive. Okay, what else? Let's talk about focal length of a concave mirror. What will be the sign for focal length of a concave mirror? A concave mirror has a real focus which is in front of the mirror. Focus is somewhere here. You've done the diagram. So focal length of a concave mirror will always be negative. Focal length of a convex mirror, if I say, convex mirror has a focus behind the mirror, so the focal length will be positive. Fine. So if you are given that a concave mirror has a focal length 20 centimeter, that means f will be minus 20 centimeter. If you are given a convex mirror has a focal length 20 centimeter, then f will be plus 20 centimeter. Fine. Now, so this is about the focal length. What is left? Let's talk about magnification now. Sign of magnification we'll be talking about. But I hope what we've just now discussed is clear. For mirror formula, we have to take U, V and F, and we've discussed what sign can be taken according to the sign conventions. And for the magnification formula, we need HI, HO, and the signs we've already discussed. Fine. Now we're going to talk about the sign of the magnification. Fine. Now, so I'm rubbing this, and now we are going to talk about magnification in a bit details. Now, in case of magnification, M, we know M is HI by HO, height of image by height of object. So if we take this into consideration, what will be the sign of magnification for a real image? Now, for real image, height of image is negative, whereas height of object is positive. So the sign for magnification will obviously be negative. So magnification for a real image, when the image is real, the magnification will be negative. Fine. And magnification sign for a virtual image will be positive. Why positive? For a virtual image is always erect. That means height of image is positive. It is above the principal axis. Height of object is always positive. So virtual image, the magnification will be positive. Will be, for example, in a question, if it is given that a mirror forms a 3 times magnified real image, that means M is minus 3. And if a question says a mirror forms a 3 times magnified virtual image, then M will be plus 3. So sign assigned is minus and plus. We'll talk about magnification in a little more details. Now, so sign we've already discussed. Now let's talk about the values of magnification. Now M is HI by HO, right? And I'm giving you a few values, and we'll analyze those values and tell us what type of image is it. By just looking at the value of magnification, we can actually tell what type of image it is. For example, let's say M is plus 1. What do you mean by this value? How can we analyze the type of image? Now, positive means the image is virtual and erect. Okay? 1, what is 1 signifying? 1 value is 1 means HI is equal to HO. Right? When HI and HO are equal, then only the value can be 1. So this means that image is virtual, erect and same size. That means height of image is equal to height of object. So here the sign tells us whether the image is virtual or real, and this value tells us the size of the image. So if it is, we know that if it is positive, it is a real image, virtual image. If it is negative, it is a real image. Now if M is equal to 1, that means HI is equal to HO. If M is greater than 1, that means, if M is more than 1, that means height of image is more than height of object. If M is less than 1, that means height of image is less than height of object. That means here we'll say the image is same size. Here we'll say height of image is more than height of object. That means we say image is enlarged or magnified. Here height of image is less than height of object. We'll say image is smaller in size or diminished. So this is how we can read the value of magnification. The sign minus and plus tells us the image is real or virtual, and the value 1, more than 1 or less than 1 tells us whether the image is same size, larger than the object or smaller than the object. Fine. So we'll take few values of M and analyze and see whether we can read and we can find out the nature of the image formed by this. So M is equal to plus 1 we've already discussed. The image, if M is equal to plus 1 says that the image is virtual, erect and same size. And what type of mirror? Obviously this is a plane mirror. So plane mirror, in case of plane mirror, the image is virtual, erect, same size. So the value of magnification will be plus 1. Let's talk about now m is equal to minus 1. M is equal to minus 1 means, minus means it is real image and inverted obviously, and 1 means it is same size. Real inverted same size image, and a lot more information we can gain about the type of image from here. Real inverted same size, this means which mirror we are talking about? That means the mirror is concave, because a concave mirror can only form real inverted same size image, so it is a concave mirror. What other information we can gain? We also know that the object is at C. Because of the object is at C, the image is real inverted same size. So just from a value of magnification, we can derive such a lot of information. Fine. Let's talk about, okay, let's say now m is plus 2. What do you mean by this? Plus 2 means virtual erect. Plus means virtual erect. 2 means m is more than 1. That means height of image is more than height of object. That means image is magnified or enlarged. So virtual erect and magnified. That means virtual erect magnified image is formed. Which mirror we are talking about? Obviously the mirror will be a concave mirror, because a concave mirror can only form virtual erect and magnified image. And what will be the position of the object? Obviously between P and F. Only in case object is between P and F, the image formed is virtual erect and magnified. Let's analyze few more values for magnification. So m is, let's say m is plus half. Again, the plus sign means virtual erect image, and half size means diminished. Half means HI is less than HO. So if it is diminished, virtual erect diminished, which mirror obviously forms virtual erect diminished image? It is convex mirror, and in all cases actually it forms a virtual erect diminished image. Fine. So much of information we have gained using just the value of the magnification. Let's say m is minus 3. What it is? Minus means real inverted and 3 means magnified. So which mirror? Real inverted magnified, obviously concave mirror. And where is the object? Between F and C. The object is between F and C. Image is beyond C. You must remember. And the image is beyond C and it is real inverted magnified. So from this value of M, this all information can be derived. Fine. So please remember the sign of the magnification. Value of magnification tells us whether the image is virtual erect or real inverted. Plus means virtual erect, minus means real inverted. And the value tells us whether the image is same size, magnified or diminished. Fine. If it is equal to 1, same size, more than 1, magnified, less than 1, diminished. So this is how we can analyze the value of magnification. Let's do a small question, a very simple, a small question to understand how we solve the numericals. And let's say that an object is placed at a distance of 20 centimeter from a concave mirror of focal length 15 centimeter. Now I have said the object is placed at a distance of 20 centimeter, that means u is 20 centimeter, and obviously u is always taken negative. Focal length of the concave mirror which is given to us is 15 centimeter. It is a concave mirror, so f will also be minus 15 centimeter. We have to find the position of the image, that means we have to find out v in this case. Fine. So if I'm talking about a simple question where we are given the position of object and the focal length of the mirror, and we have to find the position of the image. When we are finding out the position of the image, we will not assign any sign here. The sign of v will come automatically, and that sign will help us to find out and verify also whether our answer is correct or not. So if we use the mirror formula, it is 1 by f is 1 by v plus 1 by u. This is minus 1 by 15, 1 by v, we have to find out, and this is u is minus 20, so it will be like this. So minus 1 by 15, and this comes this side, plus 1 by 20 is 1 by V. If you take the LCM, let's say this is 60, minus 4 plus 3 is 1 by V. From here we are getting V is equal to minus 1 by V is equal to minus 1 by 60. That means V is equal to minus 60 centimeter. Minus sign has come on its own. And minus V means the image is real image. Negative means real image is formed. And we can verify here F is 15, U is 20. That means the object is between F and C. So the image should be formed beyond C and real inverted. And it's real inverted and beyond C only. F 15 है, that means C is at 30 and the image is formed beyond C. You can also find magnification from this. What will be the magnification of the image formed? M we know is minus V by U. It will be minus V is minus 60 and U is minus 20 and that is minus 3. That means M is minus 3. That means a real inverted, and minus means real inverted and 3 means magnified. Real inverted magnified image. So with the help of the answer, we have also verified that we are getting the right nature of the image. So if we can write the nature of the image also from here, just by looking at the sign of V, we can write down the nature of the image. And the image is real, nature is real inverted, and size is magnified. Obviously M is 3, so that means size of the image is magnified. Right? So this is a simple question based on the sign conventions and mirror formula. I hope you've understood what we discussed today, and we'll learn more in the next class. Till then, thank you, and that's all for the day.